This is a presentation of my implementation of a rule-based system in the MicroRTS engine. This rule system is configured to control a player's actions for certain units in an RTS simulation. This rule-based system controls an individual unit's actions as well as their objectives. The rule system examines the state of the game, looking only at what can be seen, then makes decisions based upon that. The rule system implemented here is able to use variables to create generic actions for units fitting certain descriptions. This is somewhat limited though, as the variables that the system examines must be passed as actual values. Or rather, they must be declared before examining whether these rules would pass. This was done to save programming time and execution time. The rule system here examines about 8 rules. If any one of those rules is true, it will immediately execute the actions linked to that rule. All rules are written as strings in reverse Polish notation. These strings consist of operators, literals, term aliases, and variables. All variables begin with a $sign. All aliases begin with an @sign. Operators are set to be typical binary operators and also value comparison operators such as less than, greater than, and equal to. All values are compared as numbers when possible, but if that fails, then they are compared as strings. The terms of the RPN string are delimited by spaces. All rules have actions. These actions are written such that they are a term and then a boolean that denotes whether the term will be added to the AI inferences or removed. If such a term is removed, then only one instance of that term will be removed. Multiple identical terms may be added. These strings are then compiled when the strings of the rules are compiled when the rule is created. If the pattern is valid, then the rule is counted as valid. When rules are evaluated, the compiled version of the rule is examined to see if there are any variables present in the rule. If there are, then the variable is replaced with the potential value and the rule is enabled. If the rule passes, then a binding is generated and immediately executes all actions that the rule has. The arbiter in the system does not examine which rules have actually fired. In terms of execution flow of the AI agent, the agent must invoke the rule system when the get action call is made against the agent. When the call is made, the agent accounts for all units controlled by the player and feeds this data into the rule system. The rule system then interprets this information and will make decisions based off of it. Actions for individual units are based upon the actual return values from the rule system, except for the workers. The workers use much the same code as the Light Rush AI does, except that the placement of buildings is changed so that the scoring function is based upon the capacity state of adjacent squares, as well as the distance from the current point. This prevents placing the barracks at a point too close to the base, which would interfere with harvesting. The base in the game will examine whether the number of workers is at capacity. This capacity value is determined ahead of time. If the number of workers is at capacity, then it ceases to build workers. Otherwise, it will build workers when it's not busy. The operation of the barracks is a bit more complex. The barracks examines the number of light, heavy, and ranged units present under the user's control. If there are specific values set for light and heavy, there are specific values set for light and heavy as values of when the user should stop building those. If the user is at capacity for light units, then it produces heavy units. If the user is at capacity for light and heavy units, then it will instead produce ranged units. This prevents overcrowding. Actions that the units take are based upon the presence or absence of enemy units. If an enemy is present and in attacking range, then the units will attack the nearest closest enemy. If no enemy is present, then the units will randomly wander. This random wandering works as a form of exploration and helps the units to not crowd the barracks or the harvesting, in turn helping the player to produce a greater number of units. The best way to improve the AI would be to configure the units so that they're part of a particular group. This clustering would be very helpful because it would ensure that while exploring units find an enemy, they are most likely to make it out alive. Another improvement would be configuring the rule system to be pulled from an external text file, instead of needing to be bootstrapped from Java. A final improvement would be examining the pathfinding system so that multiple units do not conflict, or if they do conflict, they have some sort of resolution. This is something that I noted happened very often, where units would try to move into the same square and could not decide who should actually move, so they both froze. Thank you.